series. Montana Campus Compact is excited to return once again. This year's series will focus on the theme of Indigenous people and place, and will explore people's millennia spanning relationships with history, power, and place. This webinar series could not be possible without all of our sponsors, and so again, we want to certainly extend our gratitude to all those who have helped sponsor today's series. Today's presentation is titled A One Health Place-Based Approach to Indigenous People's Health. Our presenter, Dr. Anita Moore-Nall, is an associate professor at Montana State University. Some of the courses she teaches are Native American Studies, Alaska Native Perspectives, and Montana Indian Culture History and Current Issues. Dr. Moore-Nall has a BS in Earth Sciences with a geology option and a film and television photography option, as well as a PhD in Earth Sciences with a geology option, both from MSU Bozeman. During her PhD dissertation, Dr. Moore-Nall studied 2 abandoned uranium mining districts in Montana and Wyoming, looking for possible sources of lead and mercury contamination in the Bighorn River. The ore which was mined from these districts was taken to a processing site near Riverton, Wyoming, which left a legacy of contaminated groundwater and tailings on the Wind River Reservation, Wyoming, home to Eastern Shoshone and Northern Arapaho Indians. Along with a research interest in place affect health, Dr. Anita Moore-Nall also has interests in environmental health, traditional ecological knowledge, food sovereignty, social justice, earth science, cultural revitalization, and art, just to name a few. Dr. Anita Moore-Nall has been involved in many grant-funded projects, such as a project titled Digital Storytelling, Bridging the Gap in Place-Based Science. The objective of this grant was to create climate-themed digital stories from different parts of Alaska from students' perspectives using traditional and family place-based knowledge. As part of her postdoc at UAA, she planned to develop an American Indian Alaska Native CTRP small grant for community health and research to establish an exercise program for Alaska Native elders diagnosed with Parkinson's disease to increase quality of life and slow progression of the disease in some of this population. Dr. Moore-Nall has also worked with projects that involve tobacco cessation, cultural revitalization through language, dance and art, MMIP issues, and climate change awareness. There are a few quotes that I wanted to share today that are on Dr. Moore-Nall's profile. And so Dr. Moore-Nall has stated that earth science can be thought of in an Indigenous or a Western science perspective. Earth science from Western view is often compartmentalized into many separate disciplines or fields, then related to the larger or big picture. Earth science from an Indigenous view is about the knowledge of the whole environment and knowledge of the whole ecosystem, usually based on where peoples are living and the knowledge of generations before. Native thought and science, also known as Indigenous knowledge, everything is connected, and health is related to place and time. Environmental health can be presented in the same view. It is inherently interdisciplinary, with input from geology, geography, chemistry, ecology, statistics, and medical health, epidemiology, toxicology. Related disciplines require to understand the physical and social economic aspects of health as it relates to place and time. And so at this time, I will hand it off to Dr. Anita Moore-Nall. Thanks.
All right. Well, thank you, Carla, and everyone from the Campus Compact for inviting me. And I'd like to acknowledge the lands that we are all participating in this webinar on. Many of us are situated on lands that traditionally have been caretaken by Indigenous people all over North America, and many North American people are still being the stewards of these lands, and so we acknowledge and welcome everybody else to use these lands as well. So I am going to share my screen and talk a little bit about this project. I don't know, can you see just the screen, or is it showing me?
Yeah, we can see your screen.
Okay. Is it showing the presenter slide too, or just the main slide? So, my talk today is called One Health Place-Based Approach to Indigenous People's Health. And I'm going to do, this is my outline. I'll do an introduction and a little bit about my background, and then talk about my PhD work here in Montana and my postdoctoral work in Alaska, and then my ORISE work that I did also up in Alaska, and then how some of this work applies to Indigenous people's health and future work that I might be doing here at MSU. So I grew up on 3 different Indian reservations. I was born on the Seminole Indian Reservation in Florida, in Okeechobee. I spent some time in the Salish Kootenai or Flathead Reservation in St. Ignatius, Montana, and then I spent most of my young and early adult life on the Blackfeet Reservation in Browning. I graduated from Browning High School. Then I am an enrolled member of the Apsalaga or Crow tribe in South Central Montana, and then I have worked in industry as an exploration geologist and also in a gold mine for a while. And I did, as Carla stated, got my PhD here at Montana State University in Bozeman. So some of these pictures, the top left is my family in Florida, my mom holding me and my dad holding my sister. And some of my work, like up in Alaska, actually stems from possibly this time that my parents spent in Florida, because later my mother and her sister both had Parkinson's disease, and both of them had it, and what was an atypical Parkinson's, so something that you get before the typical age. And I think some of it may be related to having eaten a lot of fish and things out of Lake Okeechobee, possibly. So the picture on the right is my father with me and my sister, and that was in Idaho fishing, getting some steelhead fishing, and pictures of my children when they're young, and at the Crow Fair, and a picture of myself working at a gold mine in Nevada, and then some pictures of my graduation and my colleagues at the University of Alaska in Anchorage. So you might wonder, what is One Health? And then how can this approach be applied to Indigenous people's health? So if under these pictures you see like air and plants and water, and if you think about it in an Indigenous way, these are environmental pathways. In the Western way, environmental pathways. In the Indigenous way, everything is connected. So like you would look at how is the food that we eat related to these pathways, or the air we breathe, or the water we drink, or even just the land that you're living on. Some places, such as in the Southwest, might be naturally contaminated with uranium. And so One Health recognizes the interdependence of human, animal, and environmental health, and that a holistic approach to the well-being of all will lead to an improved health outcome and enhanced resilience. And so health is a state of individual and community well-being that encompasses not only physical health, but also mental, behavioral, emotional, cultural, and spiritual health. So in an Indigenous way, looking at One Health, it's not just how your environment is affecting you, but also how your culture and your how you sit within that. So everything is totally connected. So when I first got interested in maybe looking at things on my reservation, I had attended a conference that was held at the same time as the Spring Powwow MSU in 2009. And this was talking about mercury levels in fish in the rivers from the Crow Reservation. And so I had not really even known that the rivers were contaminated with lead and mercury. And so I thought, wow, that would be a good thing to go back and try to look at that and see if I could figure out where was this contamination coming from. And so I decided I would go back to school and try to pursue something related to this and see if I could figure that out. And so that's from this project, and this project is actually still kind of going on. It's through several different variations, and they have been looking at contaminants in the river and making people aware of health effects. So the Bighorn Mountains have a very spiritual place called the Medicine Wheel, and this Medicine Wheel is actually situated between what ended up to be my dissertation area in the northern end of the Bighorn Mountains and in the part of the Pryor Mountains. And so I went up to this Medicine Wheel, and it's a place where people have gone for thousands of years, and so it's really a very special place, and it sits right in between the two uranium mining districts that I studied. So my dissertation was a very lengthy one, and it's a very Western based dissertation. So there's physical and chemical characterization of brecciation and uranium vanadium mineralization in the Madison limestone and adjacent units in the Big Prairie Mountain Mining District and the Little Mountain Mining District in Wyoming. So this is another picture of the Big Prairie Mountain area where I did part of my dissertation study. And these are the abandoned uranium mines were all along this ridge. And so these were in collapsed karst, or like caves that were collapsed, and they the uranium ore was taken out of these caves. And as Carla mentioned, these were taken down to Riverton, Wyoming, and mined down there. So this is a map that I made using GIS, which is a pretty powerful tool. And I think a lot of tribes throughout the North America are using GIS for different applications. Here I used it to make a map and showing the yellow dots are all of the abandoned uranium mines. And so there are quite a few there, and a lot of these have been basically kind of reclaimed. They've been shut down or blocked off so people cannot get into them. But I had permission and collected my samples and had a lot of these analyzed. And the Bighorn River flows right through my reservation. And So the mining districts were on both sides of the river. Throughout my work, I had known about a study that was done a long time ago that was part of the National Uranium Radiation Exposure or Exploration sites. And knowing about this database, I suggested that we also look at uranium. And so we worked with the Crow Water Steering Committee and had them take samples, and then we overlaid these with samples that were in a database already, and did turn out to find some uranium in some of the home wells. And so through this project, people were made aware that there was some uranium in some of the home wells, and learned about being able to, what are some good policies. So in this project, I sort of came in later because Mari Eggers and others were already working on the lead and mercury from the fish. And so I presented a lot of my information and worked with the communities. And so you have to establish a working relationship with any Indigenous people that you're going to be working with, to be able to do research and not be ethical and respectful, and have people be able to contribute their knowledge for this work as well. And we had people bring in their home wells samples, and then we're able to give this information back to the community as well. So I also, after the project was done and I finished my PhD, then I did go up to Alaska, and I presented this talk on GIS and community-based participatory research design in Alaska Native communities. I went to a One Health conference in Finland, and at the time I was with the Health Sciences and Institute for Circumpolar Health, as I was a multicultural postdoc. And so I will just talk a little bit about that. And this is in Alaska. So one thing is just looking at how big Alaska is. Alaska is about 1/5 the size of the lower 48 states. And so it's really a big place, and the population is really not that big. It's a little bit less than the whole state of Montana. So Montana is right around 1 million people, and Alaska, I think, is like 975,000. And so one thing, looking at all of the contamination sites in Alaska, there are probably about 8,000 known contamination sites. A lot of these have been cleaned up. This map is from the Department of Environmental Conservation. It's their contaminated sites map, and all of the little green triangles are active sites now. And yellow ones, which a lot of these are buried, are things that have already been cleaned up. And some of them might be still have what are called institutional controls. And so they might need to still go back and check and make sure that some of these things are not creating more problems. So for my project up there, I used available data and looked at the incidence. I wanted to look at incident rates of some diseases such as lupus, Parkinsonism, and cancers, and see if there was known see what kind of contaminants might be naturally occurring in these areas, see how close a lot of contaminants might be. So this site for the contamination sites in Alaska is one place that I could use for some background. And using GIS, you can get this data like this. So this was logging into the Department of Environmental Conservation's website. You could log in and see this is the same map, but all the yellow dots are all the different contaminated sites. And so you could click on a site if you were interested in working in an area and see what was that site, and look at the different levels, and see, if it was petroleum or PFAS or just what those different sites were. So as of this last year, there have been more than 8,000 sites that have been identified. The blue are all the sites that are still active, and the orange represents the like the total sites, but the amount of areas that have already been cleaned up. So it does appear they are starting to get a lot of sites that are actually now cleaned up, but it takes a long time since the span time is from before 1990 to present day now. Most of these sites that are contaminated are actually from active release from petroleum products. So 75% of these are from that. And other things, which are probably too small for you to see, but there are a lot of different things like landfills, maintenance shops or airports, seafood processing or agricultural processing, and chemical manufacturing and storage. But the main amount of sites are petroleum based, and there are a lot of military installations, which is this largest site up here. But a lot of those, the petroleum are this what the materials were that were spilled or causing the contamination. Other data that I looked at for this project were looking at mines, prospects, or occurrences. Again, the National Uranium Resource Evaluation Program is a site that was available where they looked at all of the resources throughout the whole United States when the U.S. government was looking for uranium to develop. Basically, when they were looking to develop the atomic bomb. Many of you probably watched the movie that was just won the Academy Award for about the uranium exploration and the development of the atomic bomb. And a lot of people were affected by a lot of this testing. So, but you can look through a lot of different databases and find things to be able to use for exploration or for looking at health related issues. So looking at the contaminated sites and then looking at health registry data were ways to look at these different health issues and use GIS to do this. So I looked at Medicare data. There was a study that was done by somebody else, and this is for Parkinson's. And this other study also showed that there was a high prevalence rate of Parkinson's in some regions in Alaska. And in the United States, all the really bright red areas are like the highest areas. And then the green areas are the areas that really are not that high. And so Southeast Alaska and like Kodiak Island and were the highest in this study, and also some areas in yellow here, which Anchorage is down in part of this. So I also looked at areas that had higher non-native population as compared to Alaska Native population. And so some of these areas in Southeast Alaska are areas that really maybe have a higher population of non-Alaska Native, but these areas are also still were also still high in the other study. And so when I compared the so these areas that were really high for non-natives were probably, these still showed up with the other study, which often looking at health data, a lot of times a lot of studies will not include Alaska Natives and American Indians because the population is too small. But that study still showed that these areas were still high in Parkinson's. And so I also looked at a 14-year study that was done by a neurologist who worked with only Alaska Native people. And from his study, I generated this map using his data, and it did show that Southeast Alaska had the highest Parkinson's rate at 609 compared to the lower areas, like the interior was only about 160. And so this is also showing that the Alaska Native rate for Parkinson's kind of correlated with just the Medicare data, which draws only from people that are 65 and older, because you have to be that old to be in Medicare. And so it was, so Southeast had the highest incidence of also lupus and breast cancer. And so it seems like there might be something going on down in Southeast Alaska. And so Parkinson's and lupus, both of these diseases really have no specific known causes. And they're thought to be associated with environmental contamination or sources. And they really lack being tied to genetics. There've been tests or studies done using like twins, and they're really, if you grow up in different areas, one twin might get the Parkinson's or lupus, and the other one might not. So it's probably a lot tied to environmental sources. So looking at the Parkinson's and lupus and the contamination sites, some things that I thought you could look at would be like looking at maybe leaky storage tanks. And so you can look using the GIS, look at all these different things from the available data. And so these showed active sites for these yellow ones, and the leaky ones that had already been remediated or fixed were these red things. And so people could have still been exposed to things if they had these leaky underground storage tanks. Also, mining activity. There are a lot of mines in Southeast Alaska, so maybe that might have something to do with it. If you look at just one type of metal, like lead, in streams, and you can, using available data, look at all these different things and then overlap them and see if there's a correlation between these things. But I also looked at whether or not there was possibly maybe a dioxin connection. I presented this research in Fairbanks at a conference. And so those previous studies that I just talked about in Southeast Alaska showed the highest Parkinson's and lupus, and also autoimmune hepatitis, breast cancer, rheumatoid arthritis, and prostate and non-Hodgkin's lymphoma cancer, and diabetes. All of these things are really high in Alaska, and all of these have possible environmental factors. And so really what's different about Southeast Alaska when you look at this map, one thing you would notice that it's farther south, and it's probably a warmer climate. But one of the things that I came up with later is that Southeast Alaska was the only place that had pulp mills, and the one on the left side is Sitka, and the other one is in Ward Cove near Ketchikan. And these pulp mills operated for about 40 to 50 years. And Sitka closed in 1992 and Ketchikan in 1997. And the facilities closed partly because they needed to upgrade to comply with new EPA Clean Water Act. When these pulp mills first were running, people didn't really know that dioxins were something that was produced mostly by the bleaching process. Dioxins are something that are natural in forest fires, like from the wood burning dioxins. So you can get dioxin by breathing it, but pulp mills, when they processed all the pulp, they actually just dumped everything down into these coves. And so they did that for about 40 or 50 years. And so the dioxins and heavy metals and other things that also come out of that processing were all just down in the bottom of these coves. And basically all the fish and sea life vanished during that time. And Ketchikan later became a Superfund site. Well, and just a few years ago, I think in 2020 maybe, or 21, there was a process. Some people wanted to build a new boat dock in Ward Cove, where the former pulp mill had been. And so this had been a Superfund site that had been cleaned up. And one thing that the way they cleaned it up is they put sand all in the bottom, a sand layer that was maybe 9 to 12 inches deep. And they didn't really want to disturb it so that any dioxins and different things would just slowly come back up. But there really weren't any health problems associated with this area, because it had not been, nothing had really been documented. And so once the Superfund site was cleaned up, it's just been on periodic checking every 5 years. And so they got a permit to be able to build this dock. And so now these huge boats can come into this area. And there is concern that possibly this can stir up some of that sand cap, which is holding back all these toxic dioxins and also maybe some heavy metals. But because of COVID, when the dock was finished, they really didn't have a lot of these boats coming in. But now this is something that could be a possible problem in the future if these dioxins start getting re-exposed in water. Dioxins bioaccumulate, and so when you eat fish and seafood that have been eating things that would accumulate in their fat and tissue, then if we eat them and we're the top of the food chain, then we will end up having more of that same contaminant or build up in us. So this is sort of a graphic showing how dioxins do accumulate. So it's basically conceptual drawing. And so as you see the person fishing on the end, and you could use nets and things also to fish, but the sediments on the bottom would be where some of these contaminants would be coming out, and different things down there would be eating them. And so that was the reasoning behind how the dioxins could accumulate. And this was a conceptual drawing of that dock before it was built. So as I have a few questions as an Indigenous science concerned with environmental and cultural health. And so without causing fear for the population about dioxins and eating subsistence foods, you want to really know what is out there, but is the fear of dioxins, is it greater to stop consumption of healthy foods, or is it more harmful than the worst case predictions, like the cancers that could be attributed to the dioxins, or to the developing Parkinson's or other things like that? And so as a scientist, you have to really kind of weigh in on some of these things, because eating indigenous subsistence foods are actually a lot healthier for people. And if you scare everyone and say, well, this is possibly could be really bad. So I think using traditional knowledge and talking with communities and finding out about the different areas that you are getting foods, if people know about an area that might be contaminated, then of course they wouldn't, you would want them to stop eating in those areas, but to just stop eating these areas out of fear, you need to sort of weigh those different risks and see, and so many times just the actual subsistence foods are the best to eat compared to other foods that are offering. I also wrote a book chapter looking at issues related to water common to Indigenous peoples of North America. Were part of my postdoc in Alaska. And so this part, I'll just talk a little bit about this. So this was, again, another GIS map that I made and gathered a lot of the data for all of the Canadian lands. So the Canadian lands are shown in red and orange, and the reservations in the lower 48 are all in yellow. And then Alaska actually has more corporations, and then Alaska Native villages. There's really only one reservation in Alaska. And so all of these different areas have been impacted by a lot of things that would affect water. The Alaska pipeline is represented by that black and white line right down here, and there are a lot of spills often associated with that. And the Alaska Exxon Valdez, which was a huge oil spill that was down in here because of oil that was piped down here. One of the ships had hit a rock, I think it was, and then it just spilled oil all over, and it really killed a lot of fish. And there are still people are still being impacted by this after decades. A lot of fishermen had to stop fishing and lost their kind of their way of life right down there. So in this chapter, I looked at how environmental pollution is disproportionately impacts Indigenous communities because it contaminates our foods and resources. And there are a lot of point source examples, such as contaminations of rivers and groundwater by industrial pollutants. Firefighting foams, PFAS are an emerging contaminant, which people are starting to know about all over. And of course, there's a lot of mining and milling operations. And so in Alaska, a lot of the landfills also could be now contributing to some things because so many of these are unlined. And non-point examples are things that would be like agricultural runoff from fields that have contaminants, maybe from fertilizers, and then atmospheric contamination, such as mercury from coal, burning coal, and also microplastics and biofilms that may attach to different things that might be in the water and be consumed as traditional foods. Uranium mining and milling. I looked at these for part in this book, and then also for part of my dissertation. And so some of the Wind River Reservation, which is where the ore was processed for the mines that I looked at in my dissertation area, there have been cancer that has popped up all around, and that is still going on now. Down in the Southwest, a lot of the water is not safe to drink because of a lot of the naturally occurring uranium. And so some of the wells might be just safe for livestock, and some people will still use that, even though just because they're also in a drought situation. And so a lot of this water is not, water is just one of the really important things yet. And pulp mills, as I said, I had talked about the pulp mills being possibly a source of contaminants for the Parkinson's in Alaska. And in Canada, they also had pulp mills that contributed to mercury poisoning and mercury contamination for a lot of the tribes that were downriver from the pulp mills. My last work that I was doing in Alaska was working with the Oak Ridge Science and Education as opposed Education Rise group. And I was with the EPA, and we looked at landfills. And the Regional Sustainability and Environmental Sciences program. The landfills up in Alaska are, many of them are located on permafrost, and permafrost is thawing right now, really. And so none of these landfills are lined. Well, actually one is lined and all the rest are not. And so as this active layer thaws, it is a lot of contaminants might be getting out into people's water and subsistent foods. And so this is looking at one of the landfills up in Breivik Mission. And you can see that the fencing around it is just collapsing because the permafrost is thawing. And so it's making big ponds all around it. And we did work with the different tribes. This diagram is showing how we did a co-production of knowledge and identified our partners and built relationships and tried to generate some new knowledge and then eventually to communicate the findings and apply this knowledge after we learned about this. So what we did with this is to be able to reach out to all these communities. We had a lot of webinars and newsletters, and then identified people that we could work with. A lot of this was during COVID, so it was kind of hard to meet with people in person. Plus, in Alaska, it's also just hard to do that anyway, because everybody is so far apart, and you either have to fly or take a boat. These were 5 villages that self-nominated and have participated and worked on this project with us. And these projects are actually still going on right now. Communities have been sharing areas that they were concerned about and areas that might be impacted that they collect their subsistence foods from, and using their traditional knowledge, and they could tell us like areas like the way the dominant wind blows, and if there are areas for fish camps or areas that they might collect some of their subsistence foods. And so by having community input, and they can help drive the way the research is going and work on health related issues. I know I'm kind of starting to run out of time here, but one of the things that we looked at were like the source water protection areas. A source water protection area is an area where your drinking water comes from, and this is just a schematic diagram. And so if you are collecting your water and something gets contaminated, and it could contaminate your source water. And if your water was in a well, like this house is going down into this well, and if this spill contaminated it, you would end up drinking those contaminated water. Your water might also be from a lake and be supplied by the natural rainwater. But the distance, there's a zone where you should probably not have your source water be connected to any like contaminants. And a lot of our landfills that we were looking at, some of them were within these source water protection areas. And so this is a landfill, which is a green area here, which this is a source water protection area over to the well here. And so there are actually some contaminated sites, active contaminated sites also within this area. And so this landfill, the people are concerned because there are other areas that are could be affected for their drinking water. And so Moore-Nall is one of the villages that is on the Yukon River. And so there was an active oil spill there was an oil spill in 1989 when they were trying to plow a road, and they actually broke one of the fuel lines. And so a lot of that oil went into the river, and some of it was just on snow. And so some of these sites still have not been cleaned up since 1989. These are a lot of sites in Alaska that are within source water protection zones. And so there is a large part of Alaska that probably needs a lot of work done. And most of these are Alaska Native communities. And so their health could be being impacted by the landfills. In ideas for possible research using One Health, and I know I didn't really totally go into all of that for this talk, but if you can think of how all of these different ways are related, and using the different sources of information. One of the main important sources would be to establish relationships within communities and find out the traditional knowledge, find out about each of these places, because you can't really use a one size fits all for any community. What people want to know, we need to be able to come into these communities and work with them, and to use a community-based participatory research process or a co-production of knowledge. Traditionally, so much research has been what you would term as mosquito science or parachute science, where scientists, Western scientists, come into areas, do a bunch of research, and basically take the data and take it away and do not bring it back to the communities. And so communities don't even benefit from it. And so it's like the mosquito just drawing the blood out and going away and coming back and doing it again. And so this type of practice has to change, and it is slowly starting to change. And so being able to approach communities and find out what they want and need is the best way to be doing research, and using a One Health approach where you look at the traditional knowledge, the environment where people are living, what they know about the water, the land, maybe the air, if there is a lot of impact from, especially these days, a lot of even forest fires can be impacting your health. And so that is, thank you. I hope I didn't leave much time for questions, so I'm sorry.
Thank you, Anita. We do have one question here.
Right.
And so Max McGuire asked, could Dr. Moore-Nall please elaborate on the concept of community-based participatory research and share her insights on the most effective strategies for incorporating this approach into research projects, especially how we can maintain meaningful engagement and provide updates on the impact of participant contributions, ensuring a sustained and beneficial relationship for all parties involved?
Well, yeah, thank you for that question. Like I said, the main thing is to develop that relationship with people in the community. And it can be a long process. I mean, a lot of times grants might have really a short time limit, but you really need to take the time to come into the communities and meet people. Often you may be working, you might have to have a steering council, and have it be made up of different people from the community. It would be good to meet somebody first, and then also you should learn a little bit about the culture so that you know you're not doing something disrespectful. And then, yeah, come into a community and find out what are their needs or what do they want to, and in doing that, you might be able to see how the research that you want to conduct or help with can be better met. And I guess, and then constantly following up and making visits to the community, not just staying in one area, like at the university or in an agency or something. But I don't know if
Thank
that
you.
answers the question, but yeah.
Yeah, and we only have one more comment, which is from Bob Foster, and Bob wanted to say this was an enormous amount of valuable information, and I just wanted to say thanks and wonderful job.
All right. Well, thank you.
And David James said, I know a lot of tribes have institutional research committees.
Mm-hmm. Yeah, often, the IRBs, are IRBs are Institutional Review Board. So yeah, you probably need to make connections with the IRBs because not every tribe is the same. And if you're going to be communicating or working with people like health data or even within the cultural things as well, and even like rocks and plants and things are cultural things, and so you might need to go through an IRB, both your own institution if it's through an institution, but also through the tribal IRB, and get those approved. So yeah.
Thank you. Well, I see we're at the top of the hour at 1 o'clock. And so I also don't see any more questions. So I just wanted to thank our presenter for presenting today and thank you all for attending. Just a reminder that next week at Thursday at 12 o'clock, we will have Aspen Decker, who's one of our Salish cultural consultants. And if you ever get a chance, you should look up her website. She also did our land acknowledgement in Salish on our American Indian Gateway page, and so you can take a look at that. But please join us for next week. And again, thank you to Anita.
Okay, thank you.